Okay. Let's see. And I sent an invite to Sierra, but I haven't heard from her. So,
Okay.
so have you looked over the activities for today yet?
I have a little bit, but not a ton. They seem pretty straightforward, though.
Yeah, there's just a lot of information.
Mhm. Do you suggest that we work a little bit on the first one, and since there's two, work a little bit on the second one as well?
Sounds
Just
good.
kind of do like two from each.
Yeah.
Sounds good.
And I went over, actually, I already did them today,
Oh, perfect.
but so yeah.
So yeah, we'll just review them then.
Okay. And I think the first one. Okay.
So write the words under the symbols and explain what the statement means using a picture. Okay. And, for every epsilon is greater than 0, there exists a delta that is greater than 0, such that the absolute value of the function minus L is less than epsilon when 0 is less than the absolute value of x minus a.
So
Okay.
for the picture, I guess you would just draw a pretty straightforward graph, and then you put like for the epsilon, it's just L plus epsilon and L minus epsilon on either side
Mhm.
of L on like the y-axis, and then the x-axis is a minus delta and then a plus delta, and then in the middle of that is a. If that makes sense.
Yep.
And then the function just goes through that.
Awesome. Yeah, I'm glad that we're doing limits right now. It's a lot easier than it's pretty simple than some of the derivatives we were doing last week. But all right, so number 2 says, what does the absolute value of the function minus L is less than epsilon refer to in your picture above?
So
What does 0? Okay, so yeah, so the first one.
Minus L. That's the y-axis. So that one isn't just the interval on the y-axis.
Yeah.
And then L.
Then the next question is the interval on the x-axis. Kind of basically it's saying that the area inside the absolute value is just a small positive area that is on either side of value epsilon that's on either side of L. And then the same thing with delta. A is just delta is a small value that's on either side of A.
Yeah. Okay.
So how do you read that equation? It's as the limit of x as it approaches a from the right of f of x is equal to L. And so that means, go for it.
So it would be the limit of f(x) as x is approaching a, and then so the plus, so approaching a from the right. As x approaches a from the right, the y values are moving towards L.
Yep.
You get my charger for my laptop.
Oh, no problem.
It's good.
And then the second, fourth question is basically the same, but it's the limit of x as it approaches a from the left in the function f of x is equal to L. And so that means like as x is approaching L from the right, from the left. As x is approaching a from the left, the limit is L.
Okay.
And then 5, the limit exists if and only if the limit of x to a from the right and the limit of x to a from the left of f of x. Exactly.
Okay.
Cool. So let's jump in and do, say, 2 of the second activity.
Okay.
So it's prove that the limit equation is true using an epsilon delta proof. So we have the absolute value of 3x plus 1 minus 10 is less than epsilon. And we have the absolute value of x minus 3 is less than delta. So 3x plus 1 minus 10 simplifies to 3x minus 9, which means you can factor out a 3 from it, and you get 3 times the absolute value of x minus 3 is less than epsilon.
And then you divide 3 to the other side.
Mm-hmm.
So you get epsilon over 3. Or absolute value of x minus 3 is less than 3.
Yeah.
And so when you get that, since both of them are x minus 3 absolute values, like the delta and the
I'm just looking real fast.
But yeah, so that means that delta is less than or equal to epsilon over 3.
Mm-hmm. Cool. Yeah, I was just looking at the answer key to see what it said about it. But yeah, so it's like you just kind of let delta be less than epsilon over 3. Oh, sorry, equal to? Or
it's equal to or less than.
got it. So,
Yeah.
cool. That actually makes sense.
Yeah. These aren't. Do you?
No, they're not too bad. Well, let's try the next one. So to set up the epsilon equation, you get the absolute value of 2x minus 4, and then a minus a negative 2, so plus 2 is is less than epsilon. And you get x, see, minus a negative 2 is, x minus 1 is less than delta. So that gives you 2x minus 2. So you can factor out a 2. You get x. So 2 times the absolute value of x minus 1 is less than epsilon. So then you get end up with delta is less than or equal to epsilon over 2.
To epsilon over 2.
Yep. Well, I might as well do the last two. So then we get, go ahead. So we get the absolute value of 4x plus 3 minus a negative 5 or plus 5 is less than 3. Epsilon. It's less than epsilon. I wrote it backwards, so it looked like a 3. And then you get the absolute value of x. In this case, it's a minus a negative 2, so plus 2 is less than delta. So we have those together. 4x plus 3 plus 5 is 4x plus 8. Factor out a 4. For x plus 2 is less than epsilon. So delta is less than or equal to epsilon over 4.
The last one, I guess, is basically the same, but when you get negative 2x, or it's how I wrote it, negative 2x plus 6 is less than epsilon, and then when you factor out the 2, 2 times the absolute value of 3 minus x, I guess, I don't know if you knows, but just said to remember that like 3 minus x is the same as x minus 3 because it's an absolute value. So you get the same thing. Just delta. And then when you divide epsilon by 2, so it would equal epsilon over 2 on that one.
Got it. Okay. Cool. Well, that wasn't hard at all.
Yeah, I like doing these.
No minutes were always easy. This is great. Cool. All right. Well, I think that's it.
Sounds good. Okay, and then we'll just meet next week.
Yep, sounds good. All right, and then you still have my email, right?
Yeah, I'll email this to you.
Perfect. Thanks so much. See you next week. Bye.